Hi, welcome to another Great Cow Basic training session. So today is part 15, okay? Part 15 is we're looking at LCDs, and we're going to use the software to send some information or data to an LCD. Relatively simple. Let's have a look where we are in the sessions. So we're at 15. We're going to send some information to an LCD, which happens to be serially attached. Okay, I'll dig that back a bit deeper in a moment. Tomorrow we're going to be sending a temperature sensor, just a representative sensor of data to the LCD. So we have a PIC. I'm using a 16F18313. And it's connected to a PIC kit 2. And the PIC kit 2, just so that you don't know, I've been asked, what does it look like? It looks like that. As I said yesterday, you could use any variety of programmers, okay? Now, what does it look like? It's a little small 8-pin chip. It's got some ports on it, and it's got 8 legs. Okay, so today we're going to be using the same board that we've used before. I've removed the LEDs today just because I did. I can't think of any reason why I did, but I did. We're going to connect a serial LCD, and this is a serial LCD, and it's representative of many other different LCD connections that you could have using Great Cow Basic. Then we're going to set that up in the code and then output some strings and constants and the ADC value, which happens to be attached. Okay, so I'm going to be attaching the LCD to, let me check. I'm actually going to be attaching it into screen, my pen, please. I'm going to be attaching it into here, this which is I think 5. Let me go back a slide, RA5, and we're going to be doing that. And we'll use some code we've used in the past. So what do these LCDs look like? They look like this. This is a one I found on Amazon, and they're very cheap. And essentially, they are very readily available. I found another one on the internet. They're very popular. But let's look at the one that we're going to be using today. It happens to be that one attached there. Now I've moved the layout around a bit because I needed to get this thing on board. Okay, so what we've got here is the chip and the little board we're using. I've got one wire coming out. Now the reason I'm using one wire, okay, into that backpack, okay, is because we have very limited connectivity in here. I'll explain that in a moment. Here we go. I've grabbed a series of LCDs and I'm going to show you them and why I'm using serial today to justify it. Okay, this is an LCD. This is an LCD. They're all LCDs of some sort, and these all have different connectivity options. And Great Cow Basic can control them all. This one has an 8-pin connector. There's an 8-pin connector here. If I go into the lab, I think we might see it a bit better. Let's go down here. This one has a whole series of pins. Well, I clearly can't connect the 8 or 4 data pins that was required to that little chip. This one uses a serial connection. You can see it's Chinese, therefore it's bodged up. This is a serial connection but requires 2 wires, and that's called an I2C or TWI if you're an Arduino user. And I just don't want to be setting that up today, okay? All right. You could use the same software will control one of these, which is an Arduino board. Look, it's an Arduino. It's an Arduino Shield. So what we've got is a really simple way of connecting an LCD, a bit like one of these, to my chip through one wire. Now in Great Cow Basic, we've clearly got a load more of options, and let's have no more to do. Well, let's have a look what's happening, okay? So in Great Cow Basic, I am going to do what? Let me show you where we're aiming to, and then I'll peel it back from there. So let's start with the end in mind and work back from there. Okay, I'm just going to program up the chip for you. There we go, 2 cameras. Yeah, I do need to unplug the programmer. I'm just going to show you how it's working to start with, okay? And then we'll decompose the code, okay? All right. So what I've got is some text that's just appeared on the screen. You can see it on the bottom left here. I'll zoom in on the lab for you. And then what we're going to be doing, I'm going to rotate this pot here, and it will show us the value of the pot on there, and that's what we're going to be doing. And you can see it's connected via the USR at 115,200 bits per second, okay? And I'm reading AN14. So how do I go about doing that? Well, it's relatively simple, and it's the same really for most of the LCD. So if I just take I'll take the training program from training 10, okay, and I'm going to take a copy of training 10, all right, 10, and essentially if I take a copy of that into here, we can just work through it. We're going to delete the comments, okay, all right, delete these pieces out, which is the part 1 and part 2. We'll delete this here. So basically what we've got is we've got our standard chip definition and our option explicit, and I've set the serial up to the serial 1 wire into the serial port on RA5, and we did that using the PPS tool, which is this little icon here, or IDE tools, GCB tools, where is it on there? A PPS tool there, and we need to connect the serial module to the RA5 port. We did that. Then we set up some the USART. We set up the serial connection, but this time we're going to need it a lot faster, 115,200. Now, how do I know that? Okay, well, on this particular LCD, it's got a little backpack on it, and if I reset the backpack, okay, you can see that this is a geometry. It's a 20 by. I'm sending serial data out clearly. Oh, I am sending serial data out. It's a 20 by 4 line display. It's got tabs. It's got the backlight set to 20. It's got some user-defined characters, and it's serially attached. Now, this particular backpack, okay, is invented by Evan and Stuart, and it supports serial, I2C, TWI, and SPI, and it happens to be set up just to be doing serial at the moment. Okay, so 1 wire connection. Okay, so back to our code, because we've now set it up at the correct baud rate. Okay, and that's important because it won't work otherwise. So how do I tell it it's got that particular LCD attached, that style? So I just need a constant. In Great Code Basic, we need lots of. Just type in LCD IO, LCD underscore IO, and press F1, and you will see in the help a whole series of different connections. So LCD routines help you control an LCD display. All right, and we've got different connections mode from 0 to 107. Okay, and I'll just explain them very briefly. If you let's just ignore 0 for the moment, okay, because it is advanced. Okay, all right. Number 1, if you want to drive this through a 74 HC 1 wire 595, you can. It will show you how to do it. Okay, so you can drive it through 1 wire. Okay, but I don't want to do that method. I'm using serial. I can use 2 wires through a 47174. I can use a 3 wire. I can use a standard, very common, is a 4 wire, an 8 wire bus. A number 10 happens to, and number 12 happens to be I2C TWI, and I've got a 107, which happens to be this module. It's a K107, and that I can put 107 as my in my source code, and it would tell it that I am using a serially attached K107 device. Okay, now this K107 device was initially invented by Professor Anderson in America. We've adapted it massively over the last 2 years to make it, as I said, serial, I2C, and SPI. Okay, so I've set it up, and that's the only setup I have to do. If you had to use different connections, then we will look at the demonstrations, and there are plenty of demonstrations on how to set up 8-wire, 4-wire, I2C, 1-wire, etc., etc. They're all in the help. All right. So let's just output our value. This is the serial stuff. So how do we do it? We want to clear the screen. That's CLS, and that will clear a. This will clear a. The CLS will clear the LCD. I want to print the word scaled. I want to print the value of the when I'm reading the analog port, and then I'm going to get rid of the carriage return line feed because I'm adapting this code, and I'm going to take that to read it every 100 milliseconds. Untitled. Save that. Is it training 15? I think we're on training 15. I can't remember. We'll call it 15 for the moment. And I'm going to compile that up once I've got the right screen selected in my software. Here we go. Probably fail. Oh no, it didn't fail. Look, bottom left, zoom in, screwdriver, rotate. It's reading a scaled value from 0 to 100. And you've got full cursor control. So if I go very quickly, I want to get this over and done with today. If I want to change the layout here, I simply clear the screen, and I'm going to locate. If I look at the syntax for locate, press F1, line and column, excellent, line and column. I'm going to put that value on the third line. At the first one, I'm going to say print Great Cow Basic 202 2020. Locate it on the next line. There's lots of other syntax in here. If you go into the help, there is a tremendous amount of information. There we go, a string, ADC, and just program that. We'll go out to the cameras. Now, be very clear. The syntax I'm using in here is common throughout all of the configurations. So for all of the LCD options that we've got, it's the same syntax: print, clear screen, etc., etc. So if I look at the command reference, LCD, overview, there's a whole series of different methods in here that you can use and be used, and it explains to you how to do them all. So I'm using the serial connection as a representative of connectivity. If I had a larger chip, I would have shown you with more legs, more input and output, I would have used a different method. They all have different performance characteristics, but it's extremely simple. You put one defining, you might need to define your ports. Apart from that, we are using a serial one, so we defined our serial using PPS, specified our baud rate, and we were done. With that, I'll call it a wrap. Enjoy.